Football, baseball, basketball. All these sports have many things in common, but on the most basic level, they all involve physics. One of the most obvious ways to look at the physics is through the examination of projectile motion, although in this video we will cover a bit more than just that. To help us with today's video, we have enlisted the help of two NBA superstars, guard Steph Curry and small forward LeBron James.
Now here's an example of Steph showing us some projectile motion. Steph is a great shooter and has arguably the best arc on his jump shots in the NBA. He doesn't jump very high on his shots, but his quick release and high angle allow him to shoot over taller defenders, utilizing an average release angle of 53 degrees. Steph releases his shot in an average of 8 feet off the ground, and at its peak, the ball is about 14 feet in the air. After timing many of Curry's shots from right behind the three-point line, the amount of time it takes the ball to leave Curry's hands and reach the basket is on average 1.47 seconds. Through our calculations, we were able to determine that Steph's average shot leaves his hand with 21.44 meters per second in initial vertical velocity and 16.16 meters per second in initial horizontal velocity.
Now, let's take a look at LeBron. LeBron, although he doesn't play point guard, is still one of the game's premier passers, although he does not always use finesse to pass the ball. LeBron can exert a tremendous amount of force on the ball, as he's able to pass a basketball 35 feet in a mere 79 hundredths of a second. That is an incredible 13.5 meters per second. Using the kinematic equation, which states that final velocity equals initial velocity plus acceleration times time, we were able to determine that the acceleration of a ball during James's passing motion is 75 meters per second per second. Using Newton's second law, we again determined that the amount of force needed to throw a ball at that speed is an amazing 46.8 newtons.
Through our experiment, we found out that the mu of a basketball shoe on concrete was 0.7. Since the normal force is a huge factor when determining mu, this figure can vary greatly, from 133-pound Spud Webb to 330-pound Thomas Hamilton. They are the lightest and heaviest NBA players in history. Using the calculation for friction, which is mu times normal force, and calculating the normal force, it's fairly simple to determine the amount of friction. This is helped by the fact that friction is calculated in relationship to the weight of the player, and basketball courts are level. Using the calculation for friction, which is mu times normal force, and through calculating the normal force, it is fairly simple to determine the amount of friction. This is helped by the fact that friction is calculated in relationship to the weight of the player. Using our previous player examples, Spud Webb would have created a friction of 413.7 newtons, while Mr. Hamilton would have generated 1,026.8 newtons. The average NBA player would generate 684.7 newtons of friction.
In this way, it is clear that there are many forms of physics involved in the game of basketball. Hopefully this video has provided you some real-world examples that better explain the scientific concepts inherent in the game of basketball. This is David Bloomquist.
I'm Liam Higgins.
And happy learning.
in initial horizontal velocity.